Yeah, in this video I'm gonna explain about the experiment 4, varying training sample size. So the goal of this experiment is to identify whether increasing the training data sample size affect the model's performance. So for this experiment we select the training data set from the previous experiment and randomly select 10% of the training data and then train the model. So I will train the model by increasing 10% each time, so from 10 to 20 to until it reaches 100. So for this experiment we use the three best models from the previous experiment, that is logistic regression, decision tree and naive Bayes. So for this experiment I'm briefly going to explain about the code itself. So as you can see, I use the while loop to loop the training size, so it increase every from 10%, increase 10% each time until it reach 100%. So I will select training set from the previous, I call the training set from the previous experiment, and then use the training set by increasing 10% each time. So and then I will train the model, and then since there was no space to explain all the experiment that been carried out, we for this experiment itself I'm just gonna explain about the accuracy. So once it will get accuracy and all the stuff, all the metrics, so after it's run, and it will go over here, the training size in plus in one plus equal increments, so it will increase 0.1 again, so it goes to 20 and will run the code again until it reach 100%. So let's jump into the result. So first, logistic regression. So for the logistic regression is the best performance for all the training set, but for our goal, the highest accuracy was reached at 70% with 0.7264, and the lowest accuracy achieved at 10%, 0.722. So as you can see for this, it's same. There was an increasing trend from 10 to 70%, but it slightly drops at 80 and relatively consistent between 80 to 100. So as you can see, it seems the accuracy increased from until 70%, and beyond that, the performance, the accuracy of the model performance doesn't have a significant improvement. So the next one would be the decision tree. For the decision tree itself, it was the lowest performance for all three data sets. The highest accuracy achieved for decision tree is 0.6377 at 100% increment, and the lowest is 0.6247 at 20% increment. So as you can see, there was an increasing trend from 10 to 100%. So in this experiment, it proved that at 100% increment with the 100% training set sample size has been used, the performance accuracy is high. And the last one is Bernoulli naive Bayes. The highest accuracy achieved at 0.71042 at 50%, and it was relatively consistent from after beyond 50%. So and the lowest accuracy was achieved at 10%. For this accuracy itself, for all the sample size are almost consistent, so we unable to identify the best subsample for this Bernoulli Bayes. So in conclusion, the experiment highlights the importance of selecting appropriate training data based on the model, so it can give the optimal performance, model performance. So in conclusion, we can conclude, as you can see, increasing the training data set does yield the best performance, model performance accuracy. So that's it from me. Thank you.